Hello everyone. So I guess people asked for me to do a recording where I speak. This is what I am going to do in this time. First, obviously, make the part, etc. Have all your parts ready. Have them converted to Siemens parts, and save your model, the assembly model, in the same location as where those files are located. And I'm going to be quite quick at this. This is recorded in post, by the way, so this isn't me talking while working. I was obviously listening to music like a normal person. Ignore that. Just ignore that. That's definitely not something you need to pay attention to. There we go. First thing you do, obviously, is always put in your bass first. Putting in the bass is pretty easy. Just, put it down. Let's move our origin. And to do that, we just open up the part, set the origin, and what I meant to do there was swap back to the model. I did not. So I'm now accidentally adding a part to another part, which is going to not work. And I realized this and changed it in about, a few seconds. If you can get proficient in moving the handles, it's quite useful. Very, very useful, I would say. I usually move all the parts to where I think they should be and then constrain them. Doing this can sometimes be quite faster. There's the warning that says I am now putting parts together, so I undo that, realize my mistake, and go oops. So delete, select my main part, my main assembly, and I add the part again. Don't do that, it wastes time. Be very careful about your selections, it's very important. So again, I'm just moving it to where I think it should be, rotating it a little bit. Remember, this thing rotates in 5s. So even if you put it in wrong, you can just sort of increment it in 5s until you get it to be what you need, always. You don't have to worry about, I think, opening up a page and drawing some lines, like so I said, but yeah. I'm just sort of scrolling through because there's no real order to this. I think I'm looking for the L block. No, not the L block. I wanted this. No. Apparently not any of these. What am I going to put in? Oh, I guess I decided on this. Swapping to get to the handles very quickly, just tap constraint and then move, and then you can get to that very quickly. I do that quite often, which is constraint, move, and then you can get the handles. The handle, by the way, is obviously the thing that looks like a system data point, datum sys point, whatever the hell it's called. Yeah, so you see this one gets kind of weird, it gets put in weird. I don't know what happened there. So I quickly just fix it, to the best of my ability. A little bit of messing around with some angles and I can get it to be what I want. I get it to be pretty much XY fine, and it doesn't really matter if this is in any way in the right position before you constrain them, because the constraints just lock them into the exact position you want so long as you select the right thing. So this is more just my method. You don't have to do it like this, you can do it however you want. You can just pop in every single part on the bottom, move them kind of farther away from each other so it's, visible and you can see each part, and then constrain them. There's another way of doing it. To each his own. I really hope this recording comes out fine, because I can't edit it. I really hope it doesn't break. This didn't take me very long, considering we have like 4 hours. If the test we have on Wednesday is similar in size to this, or maybe slightly larger, it should be possible for everyone to complete it. Just practice this design again. If you've done it once for the assignment, do it again on your own, and you'll see you'll do it twice as fast, maybe 3 times. I remember the first time I did this, it took me, a few hours that I spent messing with it, and then I still couldn't get it to be done. The next day I asked Sir for some constraint advice, and then I was able to finish it. Again, I'm just putting in all my parts. Awkward silence. Again, if anyone doesn't like my voice, they can, not tell me that, because that would, hurt my pride, confidence. What little of that I have. Again, I'm just looking for things to put in. I'm just trying to put in as many parts as I can. Constraint, moved again to grab the handle. Move that to where you think it's going to be. I end up getting this quite on point, because I look for the 60 degrees, which is going to be 30. Obviously. There you go. There. I'm seeing how close I got them to the actual points, and I realize it's quite far off, but it should work. I'm gonna add some constraints here. For a part that you don't want to move almost at all, then there's usually, I think, 2 or 3 constraints to really keep it from moving. So I select the bottom, the side, and then I add a touch on the inside there, and that really constrains this part to be not moving. So long as it's connected to that fixed part, it will never move. Yeah, so there you go. Check that. I try and move it there. Sometimes when you want to test moving, it's better to move the X, Y, and Z's, like grab the arrows, because then you're 100% sure it's definitely not moving. The most used constraint is almost definitely infer axis. And then touch. Touching with touch, obviously the first one you select is the one that moves. So you shouldn't select the fixed item and then move the fixed item to the other. That won't work. You should always select whatever you're moving to the other. So main part, sub-main part, etc. You'll see I select the loose parts, then attach them to the other parts. There's sort of an order to these. Well, there is an order to them. Do it like this. Whatever you're attaching, just select that first. As you can see what I'm doing here. Also, this can be kind of risky, what I'm doing now, which is I'm doing them all in the same constraints menu. I open the menu and I put them all in, which means if I make a mistake and I press Ctrl Z, they'll probably just all disappear and I'll have to do them again. So if you're confident you can do it quite quickly, then do that. Okay, so check here. These parts fit perfectly together. There's zero tolerance, which isn't always going to be around. We might have in the test, there might be a not zero tolerance. What I did there was I used a touch and I brought the pinion inside of the part. I knew where to touch. It was just a face to a face and then it was done. I used an align there, quite obvious, hopefully, and things. Now I'm going to be annoyed in a minute, which is that I forgot to align 2 holes on the sleeve and the pinion handle. I'm quickly adding a constraint for distance. You can usually select sort of the edge of a object. It becomes just a line. It didn't let me do that there, but it ended up working. I was trying to get that to work there, seeing what was up. In case you're wondering why my constraints menu is larger, I went to the top left. There's a little cog there, and you can add more options to your menus. Not with all of them, but I usually check to see if there's any other options. There I've added the 2000 constraint, which is specified in the drawing. And now, there's the thing I forgot to do, which was make sure the rotation on those is right. So now I try and mess with some constraints. You can do this if you want to add new constraints or fix parts, is hide the constraints so that you can move the parts. That's what I'm trying to do here. And I realized I deleted the wrong constraint. I hid a constraint on the L block, not on my sleeve. So I'm gonna put that back. There we go. And now I'm going to look for the actual face I meant, which is this one. And then I forgot, I also have an align, so it's still not going to work. It's going to move the whole thing again, which is, again, I'm smart. Again, if my voice is annoying, keep it to yourself. A lot of people just want to hear someone talking about this stuff. I tried to hide it there. I thought that would be a smart idea, and then I realized that's not a smart idea because then I can't add a constraint to it. I'm very smart sometimes. Anyway, as you can see, this isn't easy. None of this stuff is easy. It just takes practice. And while it doesn't take me very long to do this whole part, that's because I've done it like 5 times. And I've talked to people who were doing it. And I've like, given advice and parts to other people. They've given me advice. I'll show you some of that. I'll tell you who gave me great advice for one part here. There you go. And that pops in. Surprisingly, that just sort of locked it in, and I was very happy. I didn't even need a line there now. The line I used to bring the pinion in before. And now I'm missing some parts, so let's add some more parts, I think. Yeah, there we go. There's the pin. So now this pin is unspecified at actually what distance it goes in. So I use infer axis and I lock it in, pretty much. And then there is no specified distance it goes inside, which means you should use your own discretion. I grabbed it, I pushed it in, it looked kind of in the middle, and well, I think that's good enough. It shouldn't. If it was specified, then it would affect the center of mass. I don't think it should affect the center of mass. I'll have to ask Sir about that. If that 1 or 2 millimeters off could, affect the center of mass. I'm checking here if these rotate together. Let's see. And they do. Success. If they don't rotate here, when you did this before, what you can do is use the bond constraint on the pinion and on the bar, and that will make them rotate together. For the people who try to get their rack to move up and down when rotating it, that doesn't work. The program just doesn't let you do that. Okay, this part's tricky. So I used a line there and aligned a corner to a corner, and you'll see that doesn't work perfectly because it can still rotate in this axis as well as up and down. So we need to add just another one. That's pretty much it. Add 2 of those and you're locked into only a vertical axis. It can only move in the Z direction. Very simple, but also not obvious. It's not very obvious. So grabbing a line, then I select the top corner there. You see, select the corner, select that line, and then select the accompanying corner as well. And then it's locked in. And it looks beautiful. Look at that. It's lovely. Yeah. That's me very much proving that it doesn't move anywhere other than up and down. You can also add distance constraints if you want it to be super realistic. Essentially, it's not going to go higher than the minimum distance upwards, and it's not going to go through the bottom. So that's why before, when they have the video I made, I showed the minimum distance constraint where you can add a maximum and minimum. It's quite realistic, but not really applicable here. We don't need it for our drawing, since what he is testing isn't actually our model, but our detailed drawing. Let's grab this, I'm going to flip it around, and I'm quickly going to touch it in. Yeah. Okay. Remember, opening new assembly constraint menus saves the previous menu. That way, if you make mistakes, you can Control Z. Also, Control Z is the best. Use Control Z more often. Here again, I'm touching the object I want to move first, bringing it up to the other. Now I'm going to add a distance constraint for this because I want it to have the correct distance that he specified. You don't have to select things perfectly underneath each other. It's not like in a drawing. The program is quite good with just recognizing the difference in planes. There I changed it to 0 by accident, so oops. And then I Control Z it, so deleting my constraint, so I had to redo it. So there, and I change it to 1962. Done. Okay, so that for the most part, everything we've put there is constrained and complete. I think we're missing an angle. We might do that now. Yeah, I try to do that now. I didn't select the top there. I thought I did, but I didn't. I'm very confused as to why I didn't select. Just do it again. Programs aren't perfect. Sometimes they'll glitch, sometimes something that should work won't work. If that's the case, save and quit. However, I don't think that'll be possible in our tests considering how long those computers take to turn on and run the programs. There's the 30 degrees. Again, just selecting the axis of the handle and the plane, top of that surface, that's enough. Let's pop the plate in. Move it. There we go. Okay. Okay, here's that useful piece. Jock told me this, which was I tried to do this and then this would happen and it would bug me like to no end, which was this. It would flip around. But it turns out if you go to the you can reverse the constraint, then it makes it just right. I don't know why this is a thing you need to do, but if when you add a constraint it just flips out and goes completely the wrong direction, try reversing your constraint. I just used that there. Anyway, I'm showing you that it's locked in there. Again, two constraints will lock it in one axis, it seems. Okay, now let's get some bolts in. When you select bolts, you can actually select multiple bolts to put them in. So remember that if you need to put a lot of the same part in, it can be quite useful. There it is. And I select 4. Quickly constraints, move, and there they are. They don't put in a perfect or a certain orientation, as far as I know. They put in like a sort of one on, one off. I don't know how to describe that, but it's good enough that you can get all the parts in there and quickly constrain them. So quickly use infer axis and just constrain them all. This doesn't have to take long. I think putting in all the parts, then adding all the constraints, testing your constraints obviously, and then assemblies can go by quite quickly. Most likely the most difficult parts are going to be the detailed drawings, I believe. Finding, I guess, there they are. We need 2 of those. Grab it out of the corner of my eye. Just grab it there. Pull it in. And again, you don't need to do what I'm doing. This is kind of unnecessary. You don't need to rotate it and assign it like that. And I try and be a dumbass now by grabbing the center. Grabbing the center almost never works. Use the handles, use the X, Y, and Z to really move it like efficiently. That's yeah. And then again, just some infer. The best one, infer center. Infer center axis. Ta-da. And ta-da. Okay, so apply that. Let's grab our bolts. 2 of those. Hex bolts. No, it's nuts. Yeah, it's our nuts. Apologies. There they are. I don't know if I do I do that again. Do I really need to? I do. Why do I do this? I've been doing this from the start, so I don't know if this actually might affect when you add constraints. There's a possibility that it's a possibility that it will, but I, to be honest, don't know. I just do it out of habit. So, okay, so now we have all the parts. We're all there. So let's put them together. The fastest way to do this again is just grab a touch and touch the faces correctly to each other. Also, when you select touch, obviously the constraints create those blue lines, right? So that you know where the constraints are. If you're using touch, try select close to where it's going to move to, so that the line it creates is quite small and less, horrible to look at. Yeah. So those bolts get pulled to the face, but these actually get aligned with the back. Change that to an align and align it with the back. There we go. While touch and align are extremely similar, that one slight difference is very important. Bringing something in line and bringing something to can be completely different. So I'm going to just bring that there and touch it, and now it's locked in. And I believe that's the whole assembly constrained and completed and put together. So save, obviously, and I think it's time we do some explosions. Explosion 1, name it that. And what I'm going to do now can be risky. Again, it's the whole, if you make a mistake and you Control Z or you undo, it takes away all the work you've done. Which is that I will grab things and then deselect what I've grabbed and move other things. Which is what I'm currently doing. Yeah. That was me trying to select. If you want to select something, obviously just click on it. If you want to deselect, it's Shift and then click. That'll remove the item from your selection. Very useful. It can make it quite fast. Right now I'm using the 3D view on our left there to see how I'm going to split these objects. I'm trying to get it quite similar to how they've done it. So that's easy. Then I obviously deselect the parts again. Doing this can be faster. I think it's faster. But again, if you make a mistake, then you lose everything you've changed in that from that menu. Then move it all, move the bolts away, and then those are the exploded nuts and bolts. And I close it now to save that. I've saved, I'm happy with that part, so I'm going to save it, I'm going to close it, and I'm going to try continue. So let's move this piece. It looks like this piece is actually brought forward, so that's what I'm going to do. I'm going to bring it out. And then I noticed that I haven't brought out my plate far enough out. So I'm like, okay, so, well, I'll save this. Okay, I'll bring it up a bit. And then I'll bring that down. Then I'm going to save and close it. Okay, apparently not. Okay, I'm going to select everything here. And I'm just going to move it out again to sort of in line with the picture. To our left. I'm trying to deselect everything here. This can be really risky. Because if I make a mistake here and I press undo, I'm going to have to do that all again. again, trying to mimic the picture. You won't always have a picture to mimic, so use your own discretion. Explode it so that you can see every part for the most part. I always say try to be able to see 60% of each part. And if you have reoccurring parts, you don't need to see all of them, just that they are all there. Evidence with that one bolt that's covered by the blue nut. Yeah. Bring that out to all the parts. I want to get a better fit here. I always thought it was a bit weird how we pull that part out there, and when we should pull out, I would think downwards. You could have a more compact sketch that way. Okay, and that looks pretty much identical. So I'm going to save it. And now is an important part, which is to create a view. Go to your part navigator and add a view. Name it explosion. I named it TNT because I am a copycat, and my friend named it TNT when I looked at him do this. I thought it was funny. Anyway, so now we have to create the full section front view and the detailed drawing. So save, and let's move across to drafting. Go to application tab and move to drafting. Apply, okay. I will be releasing this video after 8 AM tomorrow morning, the hand-in date, so that I do not get in trouble. Okay, I feel like that's a bit too big. It bothers me. So I want to try and fix the scale. It's so large, it's annoying me. First, obviously, make it let's add color to that. So I'm going to try and get the scale right here. Or try. I believe I fail. Okay, 0.01. How's that? So it's not 1 to 1000. Okay, that's too small. And that's back exact same size, so that annoys me. And then I think I'm accidentally, okay, yeah, 1 to 10 doesn't work. And I think I make it 1 to 10, no, 1.01, that's not gonna work. 0.01, that still doesn't work. 2, okay, that's not bad, that's a new way of doing it. 2, no, 2, 3 made it smaller, 1 again, and it's back to exactly where it was before, so I give up. I'm like, okay, I can't fix the scale on this, so I'm not gonna try anymore. I think maybe before we write the test, go and look up different scale settings and see ones that you can use for different size objects. This object is, however, way too large. Like the scale was messed up, very obviously, and so it's not supposed to be, I think, like a 3 or 4 story building sized press, a hand press. Anyway, let's create our section view here. There is a part here that I'm not including, which, to be honest, is because I wasn't able to get it right. I'm going to do some more research later on how to do this. But for the most part, this is what you should be doing when creating a section view. What I did there was remove the alignment, which lets me move that view and hide it, which is what was suggested by Sir, which is why I'm hiding it. You wanted the section view, that's the section view, so there's the section view. Okay. The bolts, you can't cut through bolts, so we have to show the bolts. So I'm going to make the bolts visible. To do that, right click, edit, and say select objects to be deselected, select both the bolts, and there they are. We need to update it first. And update, and there they are. They are no longer cut, so they're very obvious. Okay, what was supposed to happen is you must do it for all of the bolts that are visible. The only problem is I don't know how to create a section cut that changes depth. When I figure that out, I'll make a video about it. Like a 5-minute video about a section view that changes depth, showing all of the things. I'm really gonna add my tabs here. We need 2 tabs. We need a tab for material and tab for mass. I mean columns, column row, column. Fuck, I don't know. 24 minutes of speaking. This is fine. This is fine. Fine, it's fine. I swear to God. I mean, I don't swear because that's bad. Bad people swear. But if this recording doesn't save properly, I'm probably gonna want to die. And if it does, then you all heard me say that. So yeah, that's great. Again, you can mute me. I won't take offense. But if you tell me you muted me, I will take offense. So you know what to do. Just don't tell me you muted me. I changed the size there to, I think, 1.5 or 2 millimeter height lettering. You can use your own discretion for this. There I'm linking it to my TNC, which adds the balloons, the order balloons. Just select the correct sketch. And just quickly go make it look a bit nicer. The only rule, I think the only rule of thumb is that it should be obvious what you're pointing at or what the balloons are pointing at. If they're crossing over each other and it becomes difficult to see where the arrows are, then you're doing it wrong. I immediately noticed that I can make like an arc here, so then I decided to do that because I'm a child and I think it's funny. There. You can see I'm immediately doing exactly what I said. Sometimes I wish I could move the marker location, the head of the arrow. I think you can, I'm not sure. Okay, there we go. Now we have our balloons, they're quite obvious. I'm going to move this in a bit and I'm going to fix the spacing because it's obviously way too spaced. Now I make mistakes and I'm sorry about that. I don't know how to fix them. At the time I learn how to fix them, I will obviously in future videos fix them. The mistake here is that there's a problem with the mass and that there are no decimal points. And when I eventually add decimal points, they break. So I've cut that part out here. You're not going to see me mess with that. So we're almost done. A quick thing is Sir made a video on adding this sheet here I'm talking about. He made a video on this. If you want to know how to add these parts, you're going to have to go see his video because the parts I used were already defined with mass and the materials that they were made of. So I didn't have to go assign any materials and I didn't have to go set the masses to update on saves, which is something you have to do if you're doing assembly from scratch. This assembly is obviously with the parts that I used before in my other thing. You can see the mass there is ridiculous, and that's because I think the 3 decimal points that should be behind a decimal point aren't. Oh fuck, my thing just crashed. Okay, pausing the recording. Unpausing the video. My recording. The next step would be we need to print. And so I'm going to show you how I print. I print by opening a print, and then I select PDF, and then I say, yes, this, all of this, yes, do that thing. Make sure it's color, and save it in the right location, wherever the hell that may be. I'm going to save it in the name of the file where I'm saving all my other stuff. I'm going to name it something random. That being apparently assembly 7, and done. I'm going to save. I'm going to close. And let's open up that PDF and just, admire it. How beautiful. Okay, that's the wrong size. One second. Yeah, there we go. No, there we go. And that's, as far as I know, the correct method and correct final answer, minus, all the naming and stuff. So I guess, thanks guys for watching the video. I hope it helped. Any questions can be directed to the comments, or I guess if you see me in person, you can ask me questions or ask for future videos, etc. And if anyone judges me on the sound of my voice, I don't care. I don't like you.